Now, over the course of the few last video, we have only been talking about lines. So in this video, we'll move on to something a bit more complex, and that is called a plane. Now, a plane is essentially a two-dimension vectors. Let's say we have a point here, and this point, it can go say to any unit in two directions, so this direction or this direction. So it can go as much as it want in each direction. So let's say first it goes a little bit to this side, so just a little bit to this side, so it goes here, and then it start going all the way of this line, so it goes all the way to that side, so it goes all the way to infinity, to that side infinity. Now then it moves up a little bit and it goes here, and similarly this point start going all the way up there, and then it moves up again and it go all the way up there. Now for that and repeating the process, you actually get these parts all filled. Now, similarly, if you move it this side, let's say this point can move on this line, so let's say it moves this side, and similarly each point it moves up all the way. So similarly you have what we have here, and now say this point moves down rather than moves up, so repeating the process you actually get it all the way down here. So from that example we can see that from point, if it can move in two directions, any unit it possibly can, it can actually cover a whole two-dimension page, and in this case it can cover this whole screen. And that is essentially the idea of a vector equation of a plane. It is where one point is allowed to go two directions, and that create a plane. And for that we have this formula. So we have the formula where, say we have a point O A, we have a point A, and that is at O to A, and this plus mu of AB, any line starting from A, and plus lambda AC, any line starting from A, and this is what we call the vector equation of a plane. For example, we can get the point 3, 4, 5 plus mu 1, 2, 1 plus lambda 0, 1, 2, 1. So this is an example of a plane. Now you can change these number the way you like, and you can actually get another plane, but that is the basic idea of the vector equation of a plane. Now let's talk about another representation of a plane. Now actually for a plane it can also be represented in the form of ax plus b, y plus c, z equal to d, where a, b, c, d are constants. So how do you do this? So let's take an example of a vector equation of 3, 4, 5 plus say mu of 2 minus 2, 1, and plus lambda of 3, 4, 6. Let's try to solve this. This might get a bit complex because I just made it up in my mind. Now we have x, y, and z. So this is how you actually move from this to here. So we have x, y, and z. Now x, y, and z, to get rid of this. So x is equal to the top of this equation, so that 3 plus 2 mu plus 3 lambda. And that's what we get. Y 4 minus 2 mu plus 4 lambda. Z 5 plus mu plus 6 lambda. So here's what we have got. Now let's try to eliminate all the mu. So here we have x plus y being equal, which is plus these two. See what we get. So we get 7 plus 7 lambda. Pretty interesting. 7 plus 7 lambda. Well, this one. So if we want to eliminate this one, we can actually multiply z by 2 and plus this. Then the lambda which is cancel out. Sorry, the mu which is cancel out. And so we have 2z plus y. And 2z, this is 10. 10 plus 4, 14. Mu cancel out. It's 2 minus 2 cancel out. 12 plus 4, that's 16. That's 16x. 16 lambda. Right. So here, to get rid of all these, we can multiply 16 with x plus y and 7 with 2z plus y and minus them 2. So here we have 16x plus 16, 16x plus y minus 7 2z plus y. So here we have this is equal to 16 times 7 minus 7 times 14, and that gets us to 16x 16y minus 7y, that's 9y minus 14z, get 16, this is 2 times 17, that's 14. Right, so this is our final result, and you can see that this is actually the same as this one. So it is in this form, and these are the constant that goes here. Now, so that is what we call the Cartesian form. And usually when we are given a vector equation of a plane, we can always transfer it to this form. And so why is this form something so important? Let me show you something. Let me show you. From the lab example, we have this Cartesian equation. I'm just going to write it here. 16x plus 9y minus 14z equals 14. So this is our equation. And there's a funny thing about a plane. So let's say you have this sort of plane right here. So this plane actually expand out outside, but let's just say this is what we're having. And let's say there's a pencil. So we have a pencil. A pencil just like the one I'm holding here. So this is a pencil. A pencil. I'm not good at drawing pencil, but let's say this pencil poked through this piece of paper. So it's poked through right here. And this pencil make a perpendicular line with this plane. Now, as it make a perpendicular line with the plane, we actually have this funny thing called, so this has a direction, and when this thing is perpendicular with the plane, funny thing happen is that its direction will be equal to 16 9 minus 14, so that it is equal to the constant before x, over the constant before 9 over the constant before z. So that is a very fun and interesting fact about a plane, is that all the line that is perpendicular to the plane has this direction, and what we call them, these perpendicular line, we call them normal. So that is basically what you need to know for now about a plane.